I was asked to redo the video, and hopefully it'll work better this time. For lesson 22, because it didn't work real well last time. So here's a hope anyway for us. So lesson 22 is on Cramer's Rule. Cramer's Rule was developed by Gabriel Cramer, Swiss mathematician back in the early 1700s. The assignment today will be a worksheet. Hopefully you get that. If not, I should be getting one up, a PDF version up in Google Classroom, so you have it there. Okay, so what do we know about this little deal? What's very useful is that we know we can now use determinants of a matrix to solve a system of linear equations. And to find that matrix, I just use the coefficient matrix of the linear system. In other words, if I've got, oh, where's my magic pen? If I've got this system of equations right here, right there, I got ax plus by equals d and cx plus dy equals f. What I do is I look at just the coefficients of the x and y's. Notice I got the x and y's lined up first. So I just look at the coefficient matrix. This guy right here. There, see that matrix? That's what I'm talking about. So the A, B, C, D. So if I find the determinant of that matrix over here, that tells me a value. And if that does not equal 0, then the system has exactly one solution. If it does equal 0, it means we have an inconsistent, or we have a consistent dependent system, which means I either have parallel lines or I have the same line. And if that's the case, well, we can't use this method to solve it. Which really isn't completely true. Because what I can do is go ahead and find the other matrices, and that won't. No, maybe I'll talk about that later. Here we go. Okay, so now if I want to find the x variable, and I know I don't have it 0, I put in the EF. I put in these two guys here for the x values when I want to find the x. I put those values in, these two guys here, in for the y values if I want to find the y's. But I'm just using the original coefficient matrix. And now all I got to do is run the values, and we have it. So here's an example. I've got 2x plus 3y equals 7, 8x minus 5y equals 4. So my determinant matrix is a 2, 3, 8, negative 5. So I lined up my x's and y's. Apologize. Got a bit of a sticky nose today. And if I find the determinant of that matrix, I get a negative 34, which is not 0. So that means if I want to find the x and the y value, I go ahead and use that original matrix, but I replace the 2 and the 8 of the x values with the 7 and the 4. And I replace the 3 and the negative 5 of the y values with the 7 and the 4. And now all I got to do is find the determinants of the numerators. Well, negative 35 minus 12 is a negative 47. And 8 minus 56 is a negative 48. And now I reduce those down, and I got a 47 over 34 and a 24 over 17. Now this is basic algebra, which means I should be able to take this number and put it in for the x, and this number and put it in for the y, in both equations, and I did that on my calculator, and they both equaled what they were supposed to equal. So then I know 47 over 34 and 24 over 17 is the correct answer. Now, let's take a look if we got a bigger system. What if I got a 3-variable system? I will have an x column. I make sure all the x's are lined up. I will have a y column. I make sure they're all lined up. I have a Z column. I make sure they're all lined up. And then we have our constants. Now, here's something we need to know. The coefficients are just going to be the A, B's, and C's. When I want to find the Y matrix, I replace the Y values, the B's, with the D's. When I want to find the X matrix, I replace the A's with the D's. And when I want to find the Z value, I replace the C's with the D's. And then to solve it, I just put the X over the original, and the Y's over the original, and the Z over the original. So things for you to consider here. The coefficients of the variables X, Y, and Z make the subscripted A, B, and C respectively, while the constant terms use subscripted D. The ones are just saying row 1, the 2's are saying row 2, and the 3's are saying row 3. With that being said, then the denominators to find the X, the Y's, and Z's are all the same, which is the determinant of the coefficient matrix. You know, the ABC parts. And then to solve for the X, again, yes, all I did was replace the X column with the constant column, and to find the Y's, I just replaced the Y column with the constant column, and to find the Z's, I just replaced the Z column with the constant column. That's how I got those matrices. Those are my values. As long as this original one does not equal the number 0, then, magic pen doesn't like zeros, we have one unique solution. So here's an example of one. I have x plus 2y plus 3z equals -5, 3x plus y minus 3z equals 4, negative 3x plus 4y plus 7 equals a -7. So the first thing I need to do is look at the coefficients. The determinant of the coefficients of the variables. I make sure I line them up exactly in the right order. I find its determinant, and I find it's 40, which means I'm going to have one unique solution, so it's worthwhile going after. Now, here's a cool thing. If I put this in as matrix A on my calculator, I can then store that matrix as other matrices. On the Texas Instrument, you're looking for a little button that says stow, and it's got like a little arrow here at the end, which means I put in matrix. If this is my A matrix, I would say, you know, go in and make it say A, and then I would make it say, then I hit this stow button, and then I would go in and I would grab a different name, say B. And that would get it to me. When I hit enter, it'll store that matrix A as matrix B. Now, if I'm on the Casio, I got a different button. So on the Casio, yes, I've got that in there as Casio. I got that in there as matrix A. So then I go into that, you know, that menu under the OPTM, and I make it say mat, and then I have it say A, and then over underneath the big, I guess, arrow button, the move valve should move up, down, left, and right. Above the multiplication, division, and that, there's just a little arrow by itself. This looks like an arrow. That's the one I use. And then I would hit, you know, the OPTN mat button again. And then I would make sure I say mat B. And guess what? Now matrix A is stored as matrix B. Now why do I bring that up? Real simply put, if I store this original matrix as matrix A or B or C, what can then happen is I can then real easily make matrix X by just going into B and replacing that first row of numbers with, column of numbers with the -5, 4, 7. I can then make matrix C, or the Y one, real easy by just replacing the middle column. So if I store my original matrix, maybe leave it as D, and then, you know, store to X, Y, and Z, and then it's just a matter of moving those out, I can make all three of the other matrices that I need. Well, let me delete that. I wonder what that is. Okay, so then we got those three. Well, now, what's our next trick? Well, our next trick is to find the determinant of each one of those. So, since I already have it stored in the calculator as those, with the new, I just run the, you know, DET, and I get these values. So now, to actually figure out the X, Y's, and Z's, I would, you know, put each one of those in, whoops, put each one of those in, and, you know, I got the negative 40 over the original 40, the 40 over the 40, the negative 80 over the 40, and now I just, you know, have to simplify each of those out. Unlike the 2 by 2 I gave you an example of, these come out to be really nice. So these, I'm going to do my check real easily. I'm going to actually put the negative 1, 1 here. So negative 1 plus 2 times 1 plus 3 times the negative 2. Yes, that equals negative 5. 3 times the negative 1 plus 1 minus 3 times the negative 2. Yes, that is 4. And then the last one would say 3 times the negative 1 plus 4 times 1 plus 7 times the negative 2. Yes, that does equal 7. So that means negative 1, 1, negative 2, x, y, z is my solution. So that's kind of our thing there. And I think you're ready for the worksheet. Ciao.